Hi, Mr. Eckstrom here, back with some more physics basics. We've talked about units of measurement in the SI system and the English system and how to convert back and forth. We discussed units for length, for mass, for temperature, for time. And now we're going to move on to some tools that will help us to solve problems in physics. In this presentation, we're going to look at a very powerful tool called dimensional analysis. Lots of people use this in college and in high school advanced science classes to solve all kinds of linear problems. It's especially good for converting units, but it's not limited to that by any means. Anything proportional can be solved with dimensional analysis. That's the key. So here's the basis for dimensional analysis. The first factor is dividing any number by its equivalent equals 1. So for example, if I divide 5 by 5, that's equal to 1. But if I divide 2 plus 3 divided by 5, that's also equal to 1. Or if I divide 4 plus 1 by 2 plus 3, well, that's also equal to 1 because all of these things are equivalents divided by each other. That's one fact that we use. Another fact that we use is that you can multiply any number by 1 as many times as you want, and that never changes the quantity. So for example, if I have 5 and I multiply it by 1, I still have 5. But if I have 5 times 1 times 1 times 1 times 1 a gazillion times, I still have 5. So it also follows then that if I've got 5 and I multiply that by 2 plus 3 over 4 plus 1, which is 1, remember, I still have 5. So we make use of these two things, and we demonstrate our human capacity for creativity, and we multiply by values of 1, quote unquote, as many times as we need to, that we can change the units without actually changing the size of what we're starting with. Just get the units into different values. Here's an example. How many inches is 6.3 centimeters? Here's a way that I can do this. I could start out with what's given to me, 6.3 centimeters, and then I can multiply by this ratio. I happen to know that 2.54 centimeters is the same thing as 1 inch. Remember that from the measurement video. Well, what happens when I multiply by 1, this is 1, remember, because 1 inch and 2.54 centimeters are the same thing, is that the size doesn't change. It's still 6.3 centimeters. But now I have centimeters on the top here, and I have centimeters on the bottom, so they cancel. Centimeters divided by centimeters is 1. So the unit that I'm going to end up with is inches here. It's still 6.3 centimeters, but when I take 6.3, multiply by 1, and divide by 2.54, I will get inches. Let's do it. Here's a calculator, graphing calculator. Many of you are familiar with this exact same kind of calculator. Let's use it to do the calculation. I'm going to enter 6.3, and then I'm going to multiply by 1. Obviously, everybody knows what that is going to be. And now I'm going to divide by 2.54. When I hit enter, I get my answer. It's about 2.48 inches. So 6.3 centimeters is 2.48 inches, and I know that I'm right here because my units are right. With centimeters gone, 1 inch is the only unit that's left here. Let's set my calculator off to the side. Let's move on. We can do more than one of these at a time. For example, if the question was not how many inches is 6.3 centimeters, but how many inches is 6.3 meters, as we have here, I can string together a longer set of factors. So I'm going to start out again with what I'm given. That's where you always start, 6.3 meters. And I'm going to multiply now by something that converts meters into centimeters. So I can use that same factor that I did before. I know that 100 centimeters is the same thing as 1 meter. So I'm multiplying by 1 here, which doesn't change the 6.3 meters size, but it does change the unit because meters are going to drop out here. Meters are going to divide by themselves. Now I can go to the next step where I'm going to multiply by 1 inch divided by 2.54 centimeters. Now I'm rid of the centimeters as well. So I have more calculations, but the idea is still the same. Let's go to the calculator and let's do this calculation. It's 6.3 times 100. I'm going to hit enter. Then I'll divide by 2.54, and there's my answer. The answer is going to come out to be 248.03, and now it's in inches. Let's try this example. How fast is 60 miles per hour in kilometers per hour? This is a little bit more difficult because my data has two units built into it, miles and hours. But we can set it up and solve it the same way. 60 miles per hour. Per always means divide by. This is a little convention of notation that I use. Makes it easy to do dimensional analysis. Instead of times or a dot or something like that, a vertical line means times, a horizontal line means divide by. I'm going to multiply by this factor. I know that a mile is the same as 5,280 feet. Most people know that. Well, what this does for me is changes miles into feet, but it doesn't change the speed. It's still 60 miles an hour, but now it's expressed in feet per hour because the miles have canceled. I also know something about a foot. I know that a foot is the same thing as 12 inches. So multiplying by this factor allows me to get rid of the feet, and now I've got inches per hour. That's not what I want, though. Now this is useful because I know that an inch, 1 inch, is the same thing as 2.54 centimeters. Remember that from our units podcast. So with inches gone, now I've got centimeters per hour, and I'm at least in the SI system, the system I want to be in. Well, there are 100 centimeters in a meter, so multiplying by this is going to get me into meters per hour, and I'm only one step away from having my answer because there are 1,000 meters in a kilometer. Remember, kilo means 1,000. So with meters canceled out, on the top I only have kilometers left. So that's going to be my numerator of my unit. And on the bottom, I've got only hours left. And so hours remain there. Now, let's do the calculation. Pull my calculator into view here. I have to multiply everything in the numerator part here. So I'll go 60 times 5,280 times 12 times 2.54, and then it's 1 times 1, so I don't have to do anything else there. Now I'm going to hit enter, which gives me the product in the numerator. Now in the denominator I have to take 100 times 1,000. Well, it's 100,000, but I want to show you how you would do this if it wasn't such simple numbers. Hit divide by, and then make sure that you open a parentheses. Otherwise, it's going to do the divisions first and the multiplications second, and you won't get the answer that you're looking for. So with the parenthesis open, I go 100 times 1,000, close my parenthesis, and there's my answer. It turns out that 60 miles per hour is 96.5 kilometers per hour. Here's another problem. A pill contains 0.25 milligrams of a drug. How many kilograms is this? Why don't you stop the video here and give this a try. Remember, milli means 1/1000. See if you can do it. Okay, here's how it goes. I'm going to set this up like I always do by just writing down what I've got. 0.25 milligrams. Another thing that I like to do sometimes when I'm doing dimensional analysis is give myself a target to shoot for. Over here, I want to end up with kilograms. That's my ultimate objective in terms of units. How do I get there? Well, since milli means 1,000, that means there would be 1,000 milligrams in every gram. So this factor, 1 gram over 1,000 milligrams, is 1. I'm multiplying by 1, which doesn't change the weight of the drug, but it changed the unit because milligrams are going to cancel. Well, I also know, because kilo means 1,000, there will be 1,000 grams in 1 kilogram. So multiplying by this factor, again, is multiplying by 1. It doesn't change the size, but the grams now cancel. The unit that I have left is the one I want. It's my target unit, kilograms. So now I'm ready to do my arithmetic. So I go over and grab my calculator, key in 0.25, oops, backspace there, 0.25, multiplying by 1, so I don't have to even do those, divided by, then I'll open a parenthesis, 1,000 times 1,000. There's my answer. Comes out to be 2.5 times 10 to the negative 7th, as you can see. Pretty small number, but you'd expect that because it's not much weight if you're measuring it in kilograms.